Okay, here we're going to go ahead and look at the monitoring progress for 5.3. This is the second one. Remember that when you use this, what you're going to do is take a look at your answers and fast forward through this. And if your answers are correct, you're done. If your answers are incorrect, you want to go ahead and rewind to the beginning of that particular problem and listen to the instruction and take a look at what mistakes you made. So let's look here at 1. It gives me all of my details and all I have to do is stick it into my equation. Remember, our equation is this. And I'm just going to put this up here for reference for us. So evaluate each geometric series provided or described. So I have -3, that's my A1, times 1 minus my R is also -3, and that's to the 8th power. So what's interesting here is when I have something to a even number power, if I have a negative number here, that negative ends up going away because I have an even number of them, and so they cancel out. So I would expect this number to be positive, and it's going to be 1 minus a fairly large number, so I should get a negative number, and then when I multiply it by another negative number, I'll end up getting a positive. And then over that, we're going to put 1 minus r, which is -3. So minus a negative actually gives me a plus sign, right? So 1 minus -3 is going to give me 4. And then when I go ahead and take -3 to the 8th, subtract it from 1, and multiply by -3, I end up with, let's see here, 19,680, and then I divide that by 4, and I end up with 4920. And on this one, I've got the same situation. So n to the 6, it did not give me my ratio, and it did not give me my A1. So A1, I can plainly see as my first term, that's -1. And then I'm going to take 3 over -1 to get my ratio. And so I'm getting -3. Now let's use these two to check it. So if I have -9 over +3, that gives me -3. So my ratio is going to be -3. And then n is equal to 6. So I have -1 times 1 minus -3 to the 6th power. Again, we have an even number power here. So we're going to end up losing the negative that's here. And I'll end up with a negative value when I subtract it from 1. And then I'm multiplying that by another negative. So it comes out positive. And this is all over 1 minus -3. We have another same denominator. So that's going to be 4 on the bottom. And when I go ahead and do out the math on this, I get 728. So divided by 4 gives me 182. All right, let's take a look at 3. 3 is actually something that you would take a look at from a standpoint of exponential growth. So whether it's multiplying at a rate of 2 or a rate of 3, it's something that in the world of, virology, and if you're looking at bacteria and diseases and communicable diseases, you want to know how fast it will spread in addition to, how much of it takes to inoculate a person. So this is kind of a real world problem. Number of bacteria in a certain cultures doubles every hour. That is my ratio. It's times 2. So doubles every hour. If there were 30 bacteria present in the culture originally, so that's my A1, I start with 30. How many bacteria will be present at the end of the 4th hour? So n is my number of hours. So I have 30 times 1 minus 2 to the 4th over 1 minus 2. So I should have a -1 on the bottom here. And I have 2 to the 4th is 16. So 1 minus 16 is -15. -15 times 30 is -450. And then the -1 helps cancel out that negative. So I end up with 450 bacteria after 4 hours.